Hey, welcome everybody. I'm Adam Penna, and I'm excited. I'm here today to talk a little bit more about 3D printing and additive manufacturing. And very excited today to have our guest here is Ed Graham, and he's from ProtoCAM, and he's been working there for 26 years. So a great experience in the industry. And also, we have the Additive Manufacturers User Group every year that hands out D.I.N.O awards. That's a Distinguished Innovator Award that goes out every year. And this year, we have Ed, who had just received one. So Ed, welcome and congratulations.
Hey, thanks a lot, Adam. Really appreciate that. And I have my D.I.N.O on display in the background. Not sure if
nice.
It's on the camera there.
I see it there next to, of course, that wonderful model that you had shown for the surface quality that was done, the finish that was done afterwards. I remember seeing that post. That's one of my favorite things. And if you haven't noticed, it's my favorite colors of green and purple too. So, I know that's not in green and purple, but then again, it's the Hulk. So he is green and purple,
He's just kind of hanging out there behind the D.I.N.O. I think he's a little upset that the D.I.N.O is just still gaining a little bit more attention than he is.
That's right. That's right.
I think he wants to Hulk smash the D.I.N.O there, but I'm not going to let that happen.
He's very close, so you might want to turn your back there. He's getting close, buddy.
Yeah, he is. I keep my eye on him.
Well, yeah, great to have you here.
Thanks for having me. I really appreciate the opportunity and the ability to speak with you. So I've been following you a lot, and really excited about this today.
Well, thanks. It's a blessing to have people like you to speak within the industry. We have so many things that are going on that are interesting and that just there's more of it. You can look back even 2 years, 5 years, 10 years, and it just keeps rolling out and getting that much more improvement to all the technology out there. And the people working in the industry are now more educated and coming along. There's a long way to go in a lot of ways, but it's come so far, and it's exciting to see all the things that are happening, especially now, we have this pandemic we've been dealing with, and 3D printing has really stepped up and shined in a lot of different situations with supply chain and the way people are paying attention to what they can do to curb risk mitigation and to really get in there and have an alternative plan that might turn into a long-term plan. So it's an interesting time.
Yeah, absolutely, to say the least. It's definitely been an interesting time, but again, a good time to be part of this industry and a good time to be able to help out in these situations. Our industry, I felt like we really came through again in this situation to help out everybody as much as we could. Not just ProtoCAM, but the industry as a whole.
Yeah, the entire industry is a wonderful community. It is. It's a wonderful community, and everybody is really there to help each other. I've seen a lot more conversation is open, people open to helping other people just to get through things and also to bolster the industry. We have a lot of things that we could share with each other, and that's a lot of what happens at these trade shows that we've been missing this year. So again, that was a big hit, but it's nice that we do have the virtual platform, although it's not the same. I definitely miss face-to-face, but the virtual platform's nice.
Yeah, no, it is. It's a good way to get out and reach people. So for sure.
Yeah.
So, again, thanks for putting us on.
Hey, no, of course, it's a pleasure. I know that you have wonderful experience in the industry, of course, starting out on the polymer side, being a polymer engineer, and then, working with everyone going from prototype to production inside of the industry. What was that like for you, coming from even before you got started, going into your college and then going out into the world and starting the business and working now with ProtoCAM this whole time? What was it like for you before then?
Yeah, it's kind of an interesting conversation. And what's more interesting is that I actually was on your LinkedIn profile and read your About You section. Okay. And I almost felt like we're like twins in some sense.
Sure.
I mean, I really started off almost exactly the way you did, in terms of the early development, in terms of the drafting and picking that up. And I mean, I didn't hit that until high school, but for me, it was actually my entryway into the industry. For me, the drafting was, it was more of an art for me. Yep. Like I didn't know what I was doing, what I was drawing. These were the days. Look, I even have so this is some old school Ed Graham 1990 Vellum drafting.
Vellum. Oh my God, is that pencil? Also, it's not actually.
That's pencil.
It is.
Look here, I could show you the grade. Wait, maybe I shouldn't.
I could barely see it down there.
Bad grade on that one.
Yeah. Good for you.
It it was a great time for me because I went to a VOTEC high school.
Yeah.
And in ninth grade, what we got to do is we got to select 3 different programs. So I think I did like carpentry, I did mechanical drafting, which I wasn't, or it was called mechanical drawing. And I was always kind of like, you know, more, I'll call it like on the artistic side of things.
Yep.
So I was like, oh, drawing, mechanical, I'll try that. And I think I did the electrical program because the instructor's name was Graham. So I just thought maybe I'd have it in because
little
we had
edge.
the same name.
Yeah.
But that didn't work out too well.
Yeah.
But getting into that mechanical drawing, it was the first thing I think probably in my life that I actually sat down at a board and as the instructor saying, well, now what would that look like as a projected view and down? And I was just like, bing, bang, bing,
Isometric
bang.
view. Yeah.
It all came together in such a weird way. And I just really enjoyed it, you know, sitting on the board, using the triangles and the French curves and the mechanical pencils, which HB2s and how you have to sharpen them, and the little bags of eraser.
Right.
So all of that was really exciting for me, and I just completely enjoyed doing that. You know, line weights and hidden lines and all that stuff. So that kind of got my interest going, right? So what we did in high school was just, hey, here it is, draw this over here. Didn't really have any idea what any of this stuff was, but it kind of got the mind going to say, hey, well, what has been all of this stuff that I've been doing in drafting here in drafting class? And then went into mechanical engineering, got an associate degree in mechanical engineering, and then heard about this exciting plastics program that was happening in wonderful Erie, Pennsylvania. And so I decided to head up there and got into plastics. And it was kind of neat because what happened at that industry is kind of what's happening now in the additive industry. So the reason there was a development for a plastics engineering program was because they had mechanical engineers that were designing plastic products. So their thought process, well, hey, make it a thicker wall, make it a big this if you want it to be strong, beefy, thick sections, all this stuff. And it was becoming a nightmare because that's not how plastic products should be designed. You know, thin walls, nominal walls, you know, draft angles, side actions, all of those criteria that go into designing plastic products. So it was changing the way people designed to make a plastic part. And now, fast forward, we're changing the way people need to design an additive part. So I'm kind of going through this whole cycle again, just in a different industry. So it was kind of a really cool thing to get into. When I came out of the plastics program, I came to ProtoCAM right out of college, and I was brought on because we wanted to do an injection molding program. So there was a process at the time developed by 3D Systems called 3D Kel tool. And it was a process where basically you built up cord and cavity inserts in SLA, you dumped silicone rubber over them, took that out, and then you put this slurry of metal composite into it, baked it, and out came an A6 tool steel cavity. But, you know, we went through this and I came on as a young engineer at the time and designed the molds and, you know, printed out these cores and cavities. We found so many reasons that it just wasn't going to work well.
Yeah.
I mean, it was in the infancy of the idea. The idea was great. The concept was great. The execution just really wasn't there. There were too many constraints, length to thickness, length to weight, how many ribs you could have, and it just went on and on and on. And with high-speed CNC really coming out strong, you know, especially high-speed CNC aluminum, because these tools were primarily for prototype injection mold tooling. And high-speed CNC that was out there was just incredible, you know, especially being able to be programmed off of the CAD file direct. And so we decided, you know what, maybe we should let's just focus on printing and focus on the technologies of printing parts versus worrying about the injection molding side of things. And so we kind of abandoned that portion of the business. But again, it's interesting to see after, you know, 20 years, things start to cycle back, right?
Yeah.
So you're starting to see that again, especially in companies like Fortify, who have that, you know, great technology with the alignment of the fibers and filaments inside of the photopolymer to make for better injection mold core and cavities.
Yeah.
So again, it's kind of coming back around, and it's kind of, you know, it's good to see, right? Because we're advancing the technology, we're advancing the systems, we're advancing the materials. And
Yeah.
so, hey, why not revisit this? It was a great idea back then, may not have worked out, but hey, how about another opportunity to reinvent this and see, you know, if there's anything else that could come of it. So,
Yeah.
it's been really a fun ride over the years to see so many things go and come back and recycle themselves. But it's also a really fun industry to be in because of that.
Yeah. Yeah, no, that makes sense. I mean, when we're looking at things, you know, you get to a point where, you know, it can be printed out, but it might be better to do it another way. And so you have to recognize that and pull back when you can. But it always comes down to like speed, size, material. It just maybe isn't the quickest or most affordable way to do something. But we see that gap lessening over the years, you know, and you know, this
absolutely.
is, yeah, talk about that a little bit. Like you're talking about casting and injection molding. And I know like there's a real struggle, obviously, on the cost, you know, when you're looking at traditional versus an additive process. So talk about that gap a little bit over the years. Have you seen that, you know, getting closer, and what are some of the things you might see going forward that can improve?
Well, again, like, you know, we started off with this, you know, CAD development. So any CAD designer, the one thing that they probably hate more than anything is adding draft and radii to models, right? So
Sure.
nobody wants to design a part with draft and rounds,
Right.
because it's just not fun. It's that last step that sucks up all the computing time and does all the stuff that you don't want to do. So we're in a transition now. It's like, well, hey, look, could I actually design this part without that? And if I'm going to be doing it as an additive process, I can I?
Mm.
And, you know, will it be able to be manufactured that way? You know, are we going to go into injection mold tooling, or can we look at this as a true additive process? And I think we're starting to see a lot more of that happen right now. As designers are designing parts, they're starting to come to these paths of, hey, how are we going to create this part? You know, if we're going to create it as an additive part, then we don't have to worry about some of these constraints. And what a lot of these constraints do is they tie us up, and they tie up some thought process possibly as well, because wouldn't it be nice, hey, if I can make this part all in one part and put this little flow channel through here and do this, that would make this end product so much better.
Mm-hmm.
But I can't do that because of how I have to manufacture it. I have to split it apart. This has to be molded. I have side action, you know, all this stuff that goes into it. But now we're saying, hey, look, there must be some value to being able to do it as one part consolidation, and then, you know, change our end product to make it a better product ultimately. I think one of the, I'll just share a quick story with you. It may be a little offline, but
no, please. Yeah.
One of the stories that I love to tell is a story with my dad. So my dad was an engineer, not by schooling, but by trade. So he worked and built as a building engineer, and he was always fascinated by how things were manufactured and how they were made. And my whole life, my dad. So I had 4 sisters, so I was the only boy. So
another thing we have in common, I have 4 sisters. Yeah, I'm the only boy. Second from the oldest.
All right.
So,
well,
yeah.
I'm the baby. So
okay. You got that going for you. You had a lot easier time than I did, it sounds like.
Yeah, I don't know about that. But, either way.
All right.
But my dad, so because of that, he always called me boy. That was my name. Forget about what my real name was. I was referred to as boy.
Hey, boy.
What he would do, what he would do is he would walk me around to these flea markets and stuff, right? And he would take me to the flea market. Hey, boy, look at that part over there. How do you think that was made? You know.
Oh, neat.
I was like 9 or 10 years old. I had no clue. Yeah. I honestly didn't have any interest at all. But, you know, he's always picking up these castings and these old components, whatever they were. And I could just see the fascination in him as to these parts and how were they made and why were they made that way. And wow, isn't this interesting? To me, I'm sitting there as a 9-year-old kid going, Dad, can we move on? I see some toys down here that I want to get to. But it always instilled in me, you know, like his passion for that. And I think I absorbed some of that. So again, completing the full circle, I was able to now with additive get together with my dad and show him a part that we printed, a DMLS part.
Nice.
Right. So it was a little tiny part. I can't tell too much about it, but it was a medical part. And I actually was able to give it to my dad and hand it to him and say, hey, Dad, how do you think that part was made?
Oh, cool.
And he sat there and he looked at it and put his glasses on and put his extra high power glasses on.
Yeah.
And he comes back with some story about, you know, how he thinks I saw this when I was in the service over in Germany, something like this. And I said, Dad, no, you didn't. And the reason I know that you didn't is because the reality is this part, probably no more than 15 years ago, was not even possible to be created. And that's a powerful story when you think about it. When you think about what we're doing in this industry, some of the things that we're creating today, like they weren't even feasible, not even 15 years ago to ever have been created.
Yep.
And it's such an amazing thing. So I got back at him and I was finally able to return that favor.
Yeah.
Say, oh, I got you on this one, Dad.
Yeah, the man who planted the seed that made you who you are today. That's awesome that he was getting those wheels turning at like 9 or 10 years old. How was this made, you know? And even though you didn't care, your brain was sure thinking about it a little bit, you know, and that grew into where you are today. The wonderful story. Thanks for sharing that. Thanks for sharing that.
Yeah, it's just something that I always think about, you know, especially, you know, in this industry. And it does blow my mind to know that, wow, I mean, we're creating stuff today that like we couldn't have done before. I mean, it's amazing. It's really amazing.
Yeah. So at ProtoCAM, you've been doing this now, you know, taking everybody from, you know, prototype to production, looking at injection molding, casting, tooling, and being that, you know, that resource, the educator who makes people understand the benefits of it. So how has that been with the customer? You know, understanding the customer is been obviously your strength after all these years, or else you wouldn't be there, you know? So talk about that a little bit, about the interaction with the customer and understanding what they want versus telling them what they want.
Yeah, I mean, it's definitely been a journey, and it's been an evolving journey over the years. I mean, you know, back in the early days when we first started and we used stereolithography as our main technology, it was the only technology. I'm modeling stuff up in Pro E, trying to do some surfacing, pulling my hair out. That's where I got all the grays coming from.
Yeah, yep.
But at that time, when we printed something, it didn't really matter what it looked like. We made something, we presented it to the customer, and they were thrilled. They were like, oh my God, look at it. Here it is. It's awesome. Right. As long as they didn't give it to anybody in sales or marketing, it survived a couple of days.
Sure.
As soon as they did that, it was, oh, this thing broke. Oh my God, these materials are so brittle. You know, going through that whole process and learning and working with customers to have them understand, you know, what you do with it, why do you do this, what you should not do with it, and then, you know, just the progression going forward over and over again about, you know, really trying to understand customer needs and expectations is important.
Yep.
Because, you know, depending on what they're hoping to accomplish from these prototypes is, you know, maybe the technology that they should be using. There's so many technologies out there. And, you know, us especially being, I'll call it deep in the woods with all these technologies and having a good understanding. I don't know what I would do if I were an engineer at, say, Caterpillar and didn't have this in-depth knowledge of all these technologies and what materials are associated with them, what finishes you could get from them. How do you even begin to know what to look for? So the first answer to that is the best way to know what to look for is to understand what you're trying to accomplish. You know, and that's what I always try to have the engineers try to figure out. What are you trying to accomplish with this? If it's just a look-see, feely model, okay, we can select this material. If, hey, I'm going to be putting this into a reservoir and it has to hold fluids, okay, then we got to look at this one.
Yeah.
So, you know, it all depends on really, or it's an aesthetic model. So this thing has to look great. I mean, we need to paint it. We got to have colors on it, decals, because we're showing it to, you know, customers. So all sorts of different things that go into that decision-making tree. And, you know, I've always wanted to try to develop one, like an intuitive one that a customer would get on and just click their way through it. But it's hard to do that because, and I guess I'm more of a people person. I'd rather like get on the phone with you, talk to you about this and really try to get behind it. And what we ultimately wind up doing is giving people, kind of, more what they want than what they ask for.
Yep.
They might come in saying, hey, I need an SLA of this. And by the time we get off the phone, it's, no, you need an FDM and you need to do it this way. And, again, it's just, take the experience and the knowledge
Right.
that's here and work from it. And we're willing to do that and educate, because the more we get that message across to people, the better it is for everybody ultimately.
Yeah, that's that value added side of it that ProtoCAM brings to the industry. And that's a big part of helping the customer get what they really need, instead sometimes they might want something, but the actual function of what they're doing and the end purpose really needs to be refocused, because they might not know what the benefits are of 3D printing or how that can add extra value to their application. So going through that process, I've had plenty of people that have been like, print this. And it's like, why?
Right.
Let's talk about this for a minute, because you're handing me a cup, and I think you could do that.
You wanted to leak?
Yeah. So yeah,
that's funny, because that's kind of what we all ran into as an industry, right, with this whole COVID situation. So I mean, when this happened, it was kind of the wild west, right? I mean, you had homemakers making these masks, you had everybody doing everything, and I understand it was all for the intention of good, right, to help out and to make things better. But we needed to understand that there were some things that just shouldn't have been made in some technologies. The case in point, the old, we jumped in and we got involved with the N95 mask, if you will, and had some fun with the design characteristics. Making it flexible, putting silicone rim around it,
a lot more breathable
stuff. Yeah, and it was multi-jet. So when we were seeing all these ones with these, the filament type systems, we just knew that's not the technology for this. Not knocking filament technology by any means. Filament has its place, but it wasn't for a breathable mask, because we all know that it's not 100% dense. Know that there's leakage, and even us, when we got involved in this, again, it was just more intuition, more reaction. Hey, how do we help? What can we do? I got to help. I have friends, family that are in the medical profession, and they're all hurting. So what can we do to help? And ultimately, what we found out with this was really, the reality was the filtration material. I mean, that was the killer. So we could print these all day long, but if you don't have the proper filtration inside of there, and I learned a lot about N95 filtration and media, and we were getting told from suppliers, hey, yeah, use this and use that, and you can buy this, and you can buy vacuum cleaner bags, and oh man, we learned in short order. You know what? We need to get out of this, because we're probably doing potentially more harm than good. With this portion of it, certainly, getting involved in the face shields.
The face shields.
Face shields, fine, can be sterilized, and we do a lot with the there's little straps. We call them our ear savers. Go in the back there. So, and we actually send these out with every single order, even today. Nice. Whenever you place an order, you get a bag of these, because let's face it, everybody probably knows somebody that has a need for them. And I feel so bad for all of the workers, whether it's in the medical space, whether it's in the even the supermarkets, grocery stores, that have to wear these masks all day long around your ears. It's got to be really stressful. So, it felt good to be able to do something in this time to help out the community, and it wasn't about us making money, that's for sure. No,
it's a simple solution, and to be able to help and provide something like that, that's awesome. Thank you for doing that. That's really nice. I actually use those too, because it gets to be a pain wearing that out when you have it around your ears all day. So it's nice to have that strap back there and adjust it accordingly to the size of your head and all that good stuff. And I have a daughter that half the masks, she's 11, and they don't quite fit right. They're loose when you put them around her ears. So those are the perfect solution for that. And it's such a simple thing that wouldn't really be out in the market or available if it wasn't for the 3D printers. It's something that like here, there's a lot of local companies that do provide them. So it's a wonderful thing to focus on that can help and supplement the industry when things aren't quite available that easy. So little applications like that come out of nowhere just amaze me, because you're not thinking about it. And then something like this comes along where you have to take these emergency actions, and you go through again. How quick was it to go through all those iterations, those painful iterations where you said, this isn't the right thing? Yeah. Imagine if you were doing it without that process, it would have took a lot longer to get to, this isn't the right way of doing this, So yeah. It's a blessing to have it.
We're fortunate enough to have the design tools and have the machines here and to be able to do that as quickly as we could. But yeah, you're right. I mean, without these tools available to us, it would have been painstaking.
Yeah. So we talked a little bit about the customer in there, and what I've seen over the last few months has been beautiful as far as industry collaboration. It looks like a lot more people are working together. Our events have gone online. Things are virtual. There's a lot of great things that are happening that you get involved with. What have you seen as sort of industry collaboration? You talked about a little bit when you're putting together the mask and kind of reaching out to the official agencies that can give you the right updates about how to prepare things. So can you talk a little bit more about collaboration and importance of that in the industry?
Yeah, I mean, collaboration is huge. So I don't know if you heard the story about ProtoCAM back in 2013. We had a fire.
Okay, no, I didn't.
Devastated our facility. Actually,
wow.
We burned it to the ground. We had nothing.
Yeah.
But what we did have is a really strong network in the additive community, and actually that collaboration within the community helped us survive.
Nice.
I mean, we reached out to all of our, frenemies,
sure.
Our competitors, our people that we knew that we could work with to still meet our customers' demands. And we operated like that for close to a year, a good 6 months, full outsource every project.
Wow.
To try to get our customers' needs filled and met. And we brought it back. And it was that collaboration that, comes together through events like AMUG, certainly is one where you get to meet these people and collaborate and talk about technologies and what they're doing and how they're doing it. And even, with the COVID situation, it was like, well, should we seal these parts? And should we, they're multi-jet, should they be sealed? Should we work with, AMT over there to get them sealed? Should we, do this with these guys? And, it went on and on and on. And people were reaching out back and forth, what can we do for you? Hey, if you're getting too many of those and you can't fulfill it, let us know and we'll run a batch over here. So it was pretty incredible. I mean, the amount of outreach from within the industry of, like I said, friendly competitors,
sure.
All working together though at this point and just making things happen. So that was really exciting. And it just goes to show how tight of a family we have in the additive industry.
Yeah, I think everyone has that, that I've spoken with at least has that underlying passion of doing this for the right reasons. And I even recently thought of it, I used to say, I just enjoy finding new applications and talking to customers about how they can improve. And that was what I thought I did this for. And then I realized with this whole pandemic, I enjoy this because the products are saving lives, saving time, they're improving the community in one way or another. Everything I see, every development I see, every new technology, it's improving what we have in our daily life. And that's why I really do this. I love seeing those improvements, and I love seeing the positivity of what comes out of the new technologies becoming mature and becoming part of the toolkit that we have, so it's all about improvement, and that's why I get up every day, is I love to see the improvements happen and how they benefit us in everyday life. So that's been a revelation to me for sure.
Yeah, absolutely. And those improvements, along the way have not come with, some side effects, from other industries that may have been affected by this disruptive technology. Sure. I mean, certainly, CAD, we moved away from the drafting board and the pencils into a computer system where surfacing something and doing a surface model was so complicated and difficult, where today there's programs out there doing generative design and outputting 3,000 outputs in you know, just a matter of time. It's incredible to see. And then the filter, to just filter it out and say, oh, this is going to be additive, and it's going to be FDM, and then it starts to just fizzle out these design concepts to
iterations, right? The amount of iterations you have, the choices you have, you know, it's like,
yeah.
wow.
It's incredible. And then, you know, working in, so I was a plastics engineer, but when I got involved in additive, one of the areas that additive was a real benefit was in the foundry industry, castings, metal
Sure.
casting.
Yeah.
Whether we're talking investment casting or sand casting, but you know, the investment casting using stereolithography to make sacrificial parts for investment casting was huge, because it was the same concept. If you wanted to develop a new impeller or a new pump, how did you do that? Well, you designed it, and then you had to make a tool for it, and then you had to inject wax into it and send it. I mean, we're talking 12, 14 week
big process
time frame, similar to injection molding, you know. And now with the advent of this technology and the ability, and not too many people even are aware of how much additive affected the casting industry, because if you're not in that world, you have no idea.
Sure.
But it completely disrupted that industry, specifically even, again, sand casting foundry. And, you know, I feel bad because, quite honestly, there were some really skilled people out there, pattern makers, you know, these wood pattern makers that did stuff by their hand, like old world craftsmanship.
Yep.
Stuff that was just amazing. I mean, they're putting little pieces together like jigsaw puzzles, and they're doing it off of a drawing with I mean, just incredible stuff. And, you know, to see a lot of that craftsmanship kind of have to go away a little bit because of additive.
Yeah.
You know, it's that bittersweet, you know, it's just like, wow, I feel bad. But they're, you know, hopefully those guys, if they were able to maybe embrace the technology and maybe use it with some of their skills, you know, you can still pull it together and still make a win-win out of this. And I think a lot of the companies in that sand world that really are making success from it is because they still have that, they have that craftsman, that expert that know how to do it. So now all we're doing is helping him get some of his pieces faster.
Sure, sure. Yeah, that's a good point, that the tradesmen and the craftsmen out there that are actually able to do these things by hand, the traditional or older ways, that's a really, you know, that's something you don't want to lose. So I know there's also, you know, the specialty items that are still done that way, and you could really appreciate some of the old handmade ways of doing that. I started out as you know, a 17-year-old. I worked at a sign company doing, you know, all painting and hand drafting, and learn how to do lettering by hand. And so I learned, you know, a trade, you know, at 17 years old. And even inside of there, what did I see all of a sudden? The vinyl cutter came in, you know, and in the 90s, the vinyl cutters were everywhere. And I knew how to do that by hand. And I was just starting to put all that out there. Now it's coming back. The handmade signs are really a big thing now. But for a while there, no one wanted to see anything if it wasn't perfectly cut letter going on their window or their sign or anything. So everything became vinyl. And I was hurt because I was so good at doing these things by hand. And like you're saying, the artist in me from being a kid, I started out in pencil drawing and then got into painting. And, you know, I even learned how to do hand calligraphy and doing the lettering and stuff like that. So, I mean, it's an art, you know, and
you got more skills than me if you're doing.
I can't do it anymore, man. I haven't done that stuff in 20 years, you know, and my daughter likes to see me draw, but I don't draw as much as I used to, unfortunately, you know. And actually, I've been doing more of that during this time, this pandemic. I've been drawing more, and I haven't done that in years. You know, it's part of that whole art and being able to use your hands. I love that stuff. So the trades are always going to be there in different ways. They're going to grow and become different things. But you have to be able to be agile and change and recognize when something is a little bit, you know, of an improved way or an additional way that adds to the toolbox. So I had to quickly shift, you know, as soon as I saw that I was getting on. It was Gerber Graphics. I could remember that.
Okay.
Yeah. I had a Gerber Graphics vinyl cutter, and I thought I was awesome, you know, and I did sit there. And then it got into layouts and XYZ and trying to figure that out. And then you brought that over to CNC and routers and cutting. And the next thing I knew, you know, I was in the 3D world and loving it, you know? Yeah. So, you know, it's all part of it. And I think that's part of the evolution. You know, you got to be able to change, you know, even getting older, you know, it's like there's so many new things coming out, and I try to stay. Yeah.
I got a birthday coming up August 13th. So
that's
speaking
right.
Of,
hey, happy birthday, man. Oh, you got the glasses?
This is what I get. I get some readers. So now I can take these business cards and actually see what does that say? You know, this is part of that. This is part of that years in industry. So, you know.
Yeah, I'm fighting that. I'm fighting it. I have noticed I'm a little blurrier than I was, and it takes a while for me to. I need glasses myself, I'm sure, but yeah.
You know, when I recognized I needed these,
yeah,
I was trying to make a drink.
Oh,
and I was trying to follow the drink recipe, and I couldn't read it. I was like, wait, is that 1 ounce or 7 ounces? I can't see. Darn it, I need readers.
Oh, no. I'm busted. I am busted, because that's exactly me now. When I look at even like vitamins or something, I say, hey, Rhiannon, my daughter, you know, can you check? So I need them too, but what are you going to do? You know, it's funny.
Time, you know,
yeah.
I never thought I was going to get there, but I'm here. So
yeah, I'm just in denial, man. I'm right there with you. Oh boy. Well,
but I've
cool.
actually taken to the same thing with the off time. You know, I've been doing some work like antiquing furniture.
Nice.
You know, to get that art back in, you know, there's only so much Netflix and Amazon Prime videos you can watch.
Yep.
And during this time, it's better to get out with your kids and maybe teach them something.
Yep.
So we're going through and buying some furniture off Craigslist and refurnishing it and antiquing it, you know. So that's great. It doesn't have to look perfect. It can look kind of a little dinged up, and it's all good.
Yeah, that's the trend now. It looks nice when it's a little bit antiqued, right?
Yeah.
I did that with all my kitchen cabinets. I didn't want them to look all brand new. I wanted them to look antiqued.
I'm going for that. I'm going for the antique look. So
yeah, we're all getting antiqued one way or another, right? It's going to happen to all of us. No one is escaping. It's going to happen to you too. Right. Well, awesome. Yeah, no, I think it's great. You know, as far as ProtoCAM goes, you know, is there anything that where people could reach out or just go to the website, any events coming up or additional information that people could look into?
I mean, you know, that's what we're trying to do as a company, you know, with all of this pandemics going on and the fact that, you know, no trade shows. I mean, we had to cancel the rest of our shows for the rest of the year. So, you know, we're trying to be inventive and come together as a team to see, you know, what creative ways can we get out there to reach out to people. Certainly this is a great platform, so I appreciate it, and thank you again for that. It's just great to get out there on social media to try to spark some interest and you know, collaboration again with other companies and new technologies. We have our eye on a few different technologies that we're looking to bring in-house soon here, so it's going to be exciting when we do that. And yeah, just continuing to move forward and you know, push the needle, right? So,
yeah.
It's always fun. I mean, just because we're in a tough time just means that, hey, we have to be more creative, more inventive, and start to come up with some ideas on how to continue to keep going, because it's going to come back, right? I mean, it's just that, you know, we're seeing right now, everybody's having a difficult time. People are working from home. Projects got put on hold. But you know what happens when everybody comes back? It's all going to happen, and it's going to be hurry up because we're behind.
Right. So there'll be a lot of more work to do.
The floodgates are going to open when it comes back. So it'll be interesting. And it'll be interesting to see how companies change the way that they do things moving forward too, you know, from supply chain, decentralized supply chains. And I have some crazy thoughts on ideas for companies to say, hey, you know, maybe critical to function parts should be looked at in supply chains, so that, let's just say this part's an injection molded part, making 1 million of them a year, no problem. Let's say there's a material shortage, we can't get them. So every part that is a critical to function part should have an additive counterpart. So that if something would happen to that supply chain, Now they can go out to all their additive companies and say, hey, we need parts. And here is the additive design that will fulfill the needs for this injection molded part. So things like that, I think, companies, they start thinking outside of the box and how they've done traditional business. This would be just a part that's on file, right? Sitting on a hard drive, and if something would ever happen, release it, get it out, and get it printing.
Part of the digital thread.
Like that.
Yeah. No, that's awesome. Thanks for bringing that up, because that's part of the, like we were saying, the digital thread and what happens. And companies are looking at that, or should be looking at that, looking at their part catalogs and saying which one of these parts are more suited or could be a possible 3D printed part. And that goes into a lot of smart risk mitigation for companies, because things do happen. And we've seen that 3D printing, additive manufacturing could step up and fill those gaps in some of the supply chain. So where can it help you? That's the big question right now.
Absolutely.
And I think that the more people are open to looking at that, especially as things go forward with the improvements we've been seeing. So that's great. Hey, Ed, it's been wonderful having you here. Anything else you'd like to share while we got you here?
Yeah, I just want to let everybody know, again, ProtoCAM's here. So we're more than excited and happy to help anybody who has, needs out there, has questions out there. I mean, we're a big part of education. We're a big part of, the collaboration, and, reach out and let us know how we can help out.
Yeah, Ed, hey, happy birthday, man. Have a good one. And thanks for stopping by today. It's been great talking to you.
All right. Thanks again, Adam. Really appreciate it.